Alright, ladies and gentlemen, we are going to solve two-step equations today. This is for my Math 8 class, or Math 7 when we finally get to solving two-step equations. Fun times. Now this is just the way that I do it. There's multiple ways you can find online, but you might feel like this guy right here when it comes to problems like this. And you got to remember, when you solve equations like this one, what you're doing is you're unpacking the equation. You're actually doing PEMDAS, but backwards. So instead of doing parentheses first, you're going to take care of addition and subtraction. Undo that, then you'll undo any multiplication, division, so on and so forth. So it's kind of how you're doing that there. So let's take a look. You might ask, how do we do this problem, right? Well, I would respond with,
this is how we do it. This is how we do it. La, 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 la. This is how we do it.
all right, so I have to stop that before it gets inappropriate. So you can see what I did here is I drew my line to remind myself there's a left and right side of my equation. Whatever I do to one side, I must do to the other. So if this is my variable here, which is 3x, I'm going to keep that there. I'll stay there. I'm going to get rid of my 7 first. Not the 19, but the side where my variable is at. So I'm going to undo that. Inverse operation is to then subtract 7 on both sides. Now I'm asking myself, what's still happening to x? Well, it's being divided. It's being multiplied by 3 right now. So if I divide by 3, that's the inverse operation of multiplication. That should leave me with my answer, which x equals 4. But you're not done because you need to check your work. Always check your work. So is 3 times 4 plus 7 going to equal 19 is the question. Well, 12 plus 7, does that equal 19? Well, yeah, sure. 19 equals 19. So you're good to go on that. All right. So let's take a look at another example if you're still not there yet. So let's take a look at this example. All right. So once again, I draw my line. I say, here's my variable. That's what's going to stay here. I see a -1 here, so I'm going to add 1 to both sides. All right. So I do that. If I add 1 to both sides, this just drops down. I get 7b. -1, +1, that goes away, just like the one above did. And then 13 plus 1 gives me 14. All right, so now 7 times d means I'm going to do the inverse operation, which is to divide by 7. And then I can see that 1d is equal to 2. All right, so now I'm going to check my work. All right, so let's check my work. 7 times 2 minus 1, will that equal 13? Let's see. 14 minus 1, does that equal 13? Yes, it does. 13 equals 13. So I checked my work. All right, so let's try one more, and then I'll see what else you could do. All right, let's take a look. So in this example, once again, draw my line, remind myself there's a left and right side. Here's my variable. Before I handle that, I notice that that is going to tell me, get rid of this -9. Inverse operation is to add 9 to both sides. I do that. This drops down here. I get b divided by 2 is equal to 20. Now something is happening to b. It's being divided by 2. So if I multiply by 2, or 2 over 1 if you want to say it that way, those are going to cross out, and I'm going to be left with b is equal to 40. There's my answer, and here's where I'm going to check my work. So does 40 divided by 2 minus 9 equal 11 is the question. 40 divided by 2 is 20 minus 9, does that equal 11? Well, yes, it does. 11 equals 11, and there's my check. Check out part 2 for some other possible questions.